Why glaciers melt? The common question is that the glaciers start melting right now, calving and disappearing. Is there a threat? Why it's happening? What's going on? So to understand these questions, we should first look at the glaciers themselves. What are they? The glacier is melting all the time. If the glacier will not melt, probably the whole Earth will become just one big glacier, covered with ice, just as far as you can imagine. And all water will disappear. There will be no more water left in the oceans to evaporate and precipitate, because it will all trapped in the glaciers. So to answer the question why the glaciers are melting, we need to understand how the glaciers are working and why they exist in the world in the first place. If you look on our planet, the surface of our planet is uneven, and we have high mountains, lower depressions, deep oceans. We also have a different climate, depends on geographical position. Closer to the poles, colder climate and more colder days, lower average temperature, and closer to equator, the climate is warmer. So as a result, in some places, when the precipitation falling down as a rain, it might fall down as a snow. Usually it happens in the high mountains, where the temperature below zero in the moment of falling down precipitation, or closer to the poles, where the colder climate, or during the winter. Majority of northern hemisphere covered with the snow during the winter. Nevertheless, the snow melts the first spring. But there is a snow which trapped in the tops of the mountains or closer to the poles which not melting. And it does have enough warmth through the summer to melt all of that snow. When that happens, the snow stays till next winter. And on top of that snow, all the snow, which become a little bit melted from the surface, a little bit compressed by its own weight, and by the weight of the water that melted and percolate through, we have new layer of the fresher snow come on top. As a result, meter by meter, through winters, this older snow become compressed. The crystals of the snow, which are frozen water, basically, they start to rearrange themselves, grow under the pressure and temperature into the one big crystals, and as a result, the ice formed. So the ice which you have in your freezer and the ice which you have on top of the mountain, which is more than several years old, will be different ice. But it's still ice. The ice in the mountains formed from compression of old snow from year to year, exposed to changes of temperatures and pressure. The ice in your freezer is just straight away frozen water. Nevertheless, this ice in the mountains start accumulating and it's become heavier. And we know that in the mountains we have slopes. So the heavy load of ice start floating down. This old ice, start finding the passages, easier passages down the mountain slopes, just like a river does. So we call the glaciers the rivers of ice. From other slopes, smaller flows of the old ice start collecting together into the one bigger tributary, or like a big one channel, several bigger channels combined in one large one, and you have your glacier. Eventually, all this flow of ice start finding the way down the slope towards the area which is flatter, and it spread around and going down the hill as far as it can. But when it does go down into the lower areas of the slopes, you have high temperatures there, because you're going down away from the snow line towards the warmer areas. As a result, this ice starts melting, and that's when we have to look onto the balance of the glaciers. So if you melt enough of the ice than you have created in previous season, your glacier will never go down further. If it's same amount of the ice melted then accumulated during the last season, the glacier will stay in same position. So your termini or the end of the glacier will stay in same point. If you produce more snow and as a result ice during the previous several winters, the termini of the glacier will start going more further down the valley if you're not melted it enough. So in the colder periods of time, the glacier grow further down the valley. If you melt more ice at the end of the glacier that you're creating in the last several seasons, there'll be not enough supply of the ice and the glacier start retreat. retreat going up the valley, so just melting away. But it doesn't mean you're going to melt it in one season or in several years. The climate can change, or you can have more precipitation falling down, and there'll be just not enough time to melt all of the snow, all of that ice, and the glacier will stay what it is. Although the climate warmed, we'll go further down the valley. There's a very complicated calculations you need to do to figure out if the glacier gonna grow or retreat in concurrent climate, in the weather conditions in the last several years, and depends on the size of your glacier. It might take up to 10, 15, or even hundreds or thousands of years to respond for the large glacier or small glacier to the climate change. So if you want to look at an analogy, if you have the tap, your sink basin, and the drainage in the bottom of your sink basin, that could be an analogy to your glacier. So if you open the tap with the water coming in the same speed into the basin, and you have the same amount of water and the same time releasing through the bottom of the basin, whatever water is in the basin accumulated or was before will stay unchanged. This is your glacier in equilibrium. If for some reason I open more drainage, I have extra hole somewhere in the bottom of my sink, there will be more water coming out from my basin than the tap supply. And as a result, after some time, depends on the volume of my sink and the size of the holes, my sink will drain empty. So I will constantly supply fresh water, and this water will straight away melt or sink down the drainage. And if I clog my drainage, it will be melting. It will be flowing away down the drainage some water, but the tap will be keep working with the same speed. My basin will overflow. Please don't repeat this experiment at home, but just imagine that you do so. And as a result, you will see how the glacier exactly works. And after that, you will calculate the amount of water that comes to the basin, the amount of drainage that leave the basin, and depends on the size of the basin, you will look on the balance of that glacier. There's also more complicated things. If you have very steep slopes, the ice flow can go faster. So it's like a river. It's go down the valley faster because of the slope is steeper. And as a result, the glacier will flow down the valley into the warmer areas faster. It might melt away faster. And at the same time, if you have a huge flattish basin that in the higher altitudes above the snow line, it might take longer time. So there's a lot of things we need to calculate to figure out the mass balance of the glacier. There's all different conditions. We have whole continents bit frozen in, like Antarctica, and there will be different calculations for mass balance for that glaciers, which were small mountain glaciers which grow together into the one large great glacier which covered the continent. And you have situations like in New Zealand or South America, when you have very steep slopes, glaciers located closer to the equator in a quite hot climate at the base. But because the mountain is quite steep and you have a lot of snow falling during the winter, those glaciers will still exist so close to the equator. And they will behave absolutely differently than glaciers in Antarctica. So we're looking closer in all of these types of glaciers in the next videos to understand how glacier works. Summarize, if you think about the glaciers, they're always melting, because they always find a way down the valley or into the ocean where they can melt. They can't grow permanently. According to the scientists, there were periods on the planet when the glaciers grow so much, sunlight was months away from the white, shiny glaciers on the planet, away back into the space. And as a result, the planet cooled down into the snowball, so that all our planet was just covered with the ice. And then dramatic events changed it in several thousands or millions of years. However, it's just a suggestion that this was happened on our planet, but theoretically this scenario is possible. So when you hear next time the news that the glaciers are melting, just think about mass balance on this particular glacier that been observed and understand the balance of it. Realize that it will melt all the time. The question is how long this melting will cause retreating of the glacier and eventually disappearance, or growing of the glacier.